This is chapter 38 if you're watching this on YouTube, the Logarithms chapter for my new book, Overcoming ACT Math. Remember, stay for the brief summary of the stuff you should remember before attempting the problems, and then try the problems on your own before watching the video explanation for anything you're stuck on for the best results. So one thing that you're going to want to do is look at chapter 4, review the formulas there to remember like the basic formulas that you need for logarithms. So I would recommend doing that, and also remembering a couple extra things, which is that you can use your calculator for a lot of these problems on the exam. You don't even have to memorize that much. So if you get really good with your calculator, you can just do that instead for a lot of problems. And the other thing that I want to just remind everybody of that everyone seems to forget for some reason is when we have something like e to the ln of x, those cancel out and that just equals x. And a similar thing happens with log if it has a base 10 and then 10, and we assume that log has a base 10 if it's just written without any base there, that those are going to cancel out to 1. So that's another one that you might want to remember. Now, something that I teach students, this is the most likely problem that you'll see, type of problem that you'll see on the exam, is the logarithm lasso method problems is what I call them. So let me think of an example that we can do right now before we start. So we could say that we have log base 2x is equal to 3. So this is called the lasso method because you start right here with the 2. And you say, I'm taking that 2, I'm raising it to the third power, so 2 to the third power, and that's going to equal this right here, the x. So that's why it's lasso, because it kind of looks like a lasso. So to find x, if they said solve for x, I would just have to do this, and then 2 cubed is 8, so 8 is equal to x. So that's just a quick little summary and review of what you should watch out for. So let's go to number 1. The formula listed below can be used to compare the intensity of two earthquakes where I is the intensity level and M is the magnitude according to the Richter scale. In 2005, there was an 8.6 magnitude earthquake in Indonesia. In 2011, there was a 9.1 magnitude earthquake in Japan. Approximately how many times more intense was the earthquake in Japan than the earthquake in Indonesia? Okay, so let's call, if this is the formula, right? Let's call the ones like the ones that have ones like the I1 and the M1, those are going to be Japan. So the ones are for Japan. And let's say that the twos are for Indonesia, was it? Yeah, Indonesia. Okay, so if we have, let's use the formula log of I1 over I2, that's going to equal, and then M1 is the magnitude of Japan, so the magnitude of Japan is going to be 9.1, is what they gave us, minus the magnitude for Indonesia, which is going to be 8.6. And then we can simplify that. That would just be, 0.5, so then it becomes log of I1 intensity 1 over intensity 2 is equal to 0.5. Now, I can solve for what I1 over I2 is, which is like the intensity of Japan divided by the intensity of Indonesia, by saying, okay, I'm going to raise this has a base of 10, like we assume that this has a base of 10, so I'm going to use the lasso method and say I'm going to raise 10 to the 0.5 power, and that's going to equal this portion right here, I1 over I2. And so that's exactly what I was looking for, how many more times intense the earthquake in Japan was than the one in Indonesia. So then that would just be 10 to the 1/2 is how you would write that as a fraction, as the exponent. So then let's go to number 2. It says, which of the following is equivalent to y is equal to 6x? Okay. So y is equal to 6x, so that would be the same thing as saying log of 6y equals x. This is kind of like working with the lasso method in reverse, like you have to see it in reverse. So like we could check it by saying, hey, 6 to the x, I'm doing the lasso method, is equal to y. That's exactly what's right there. So this is another way of writing it, kind of like the precursor to getting this. And the reason I'm doing that is because there's something, God, I'm so bad with vocabulary. Like, I just think in numbers for math. I think it's called the change of base formula, something like that. But it basically, the reason I'm doing this is because there's a formula, and this is in chapter 4 if you have the book, that says that we could say from this that the log of whatever's right here, log of y divided by the log of 6, whatever's right here, is equal to what x is. And that's, like, in the answer choices, I saw that that was probably, like, the one that they're using, because I see, like, right here for F and G that looked like that, or it was going to be one of these. So, like, that's why I tried that first to see if it was the easy way, and then I tried to rewrite it and made the, I'm pretty sure this is called the change of base formula or something like that. But it's basically saying that you can take the log of whatever's here divided by the log of whatever's here, and that equals what's after the equal sign. So that would be y over 6, so x, this one, f. So then let's go to number 3. If log 2, all of that is equal to 3, then x is equal to, so with this one, again, we're going to do the lasso method, so we're going to say 2 to the 3rd power is equal to whatever's right here, so is equal to 3x minus 7. So 2 to the 3rd power is going to be equal to 8, and that equals 3x minus 7. So add 7 to each side. That's going to be 15 is equal to 3x. Divide by 3 on each side, and we get x is equal to 5. So it's going to be C. I saw someone asked about where to buy this book, and this is available on Amazon. I just released it this month. It's called Overcoming ACT Math by Sophia Garcia. So it's available on Amazon. There's a link in my profile to my homepage of my website, which, like, on the first page right there, it says, like, buy my book, and there's a link to it, to each of my books. So then let's go to number 4. Someone asked, where did I get 15 from? So I added 7 to each side over here. So when you add 7, you get 8 plus 7 is 15, and it cancels out over here. So that's how I got the 15. So let's go to number 4. For the equation right here, 100 is all of that, x is equal to, so we're basically trying to find x right here. So let's divide each side by 10. So then if we divide each side by 10, we get 10 is equal to log of x over 10 to the negative 13th power, and we're trying to solve for what x is. So then we could just use the lasso method to say this has a base of 10. So it would be 10 to the 10th power is equal to x over 10 to the negative 13th. And then let's see, what could we do next? Then we just multiply by, well, we could say that this is just, you could do this a couple different ways. The way I see it is I would just move this on top because it has like a negative exponent. So like negative exponent rule says that you could just move it to the top instead. So this would be equal to x times 10 to the 13th. And then what I would do is I would divide by 10 to the 13th on each side to get x by itself. So then it's 10 to the 10th over 10 to the 13th is equal to x. And then I would just use the, what's it called, quotient rule, where it says if you have the same bases, the 10s, you subtract the powers and keep the like base. So 10 to the 10 minus 13 is going to be negative 3. So then this would be F for this one. Someone asked a question. Hold on. Someone said, where'd you get the 10 power from? So when there's no number written like right here, we assume that it's supposed to be a 10. Is just like a thing that we do for some reason in math. Like how here, when it's not 10, they write the number, but if they don't write a number, you're supposed to assume there's a little 10 there, basically. So then let's go to number 5. Find the value of log 2 root 32. Okay, so this would just be, you could write it out as this equals x, right? So we're trying to find the answer, which we'll call x. And then we use the lasso method. We say 2 to the x power equals root 32. So 2 to the x power is equal to root 32. And then I'm going to try to rewrite this so that they have the same base of 2. So 2 to the x power, and I'm going to try to rewrite this so that it's written in terms of like 2 to some power. So let's see. This is already 32 to the 1/2 power because the square root is to the 1/2 power. And then I could say 32 I can turn into 2 to the something power. So I'm going to copy this down, and I'm going to say 32 is the same thing. That's 2 to the 5th. Yeah, 2 to the 5th power is equal to 32, and that's all being raised to the 1/2 power. Then I could use power to a power rule to say 5 times 1/2 is going to be 5 halves. So then this would be 2 to the 5 halves, and that equals 2 to the x power. So if these are equal, that means that 5 halves has to equal x, so it has to be D. So then let's go to this one. Oh, I was supposed to say at the beginning of the video, dang it, I forgot. So if you're one of the first 7 people that bought this book, there were a couple typos. There was literally only 7 books sold before I edited it, and now it's okay. But if you're one of those 7 people, these are the new answer choices, just so you know. And so now let's go to this one. We're supposed to find out what the value of x is. So let's see. This would just be lasso method again. So it would be x to the 4/3 is equal to 216,000. So this would be x to the 4/3 equals 216,000. So then I would just say, okay, I'm going to try to get x by itself. I can do that by raising each side to the 3/4 power, because then that'll cancel this out right there, because 3/4 times 4/3 would just cancel out to 1. So then I'm raising this to the 3/4 as well. So these cancel out, so then I get x is equal to whatever 216,000 to the 3/4 is. And then when you put that in the calculator, it's going to be 10,019. So that would be J. So then let's go to number 7. It says, assume that b and c are positive real numbers. Log b is equal to 5 and log c is equal to 4. What is the value of log b cubed times c? Okay, so let's see. Let's use, again, remember when there's no number here, it's supposed to be a 10 that you assume it is. So if we use the lasso method for log b equals 5, we would say that's 10 to the 5th power is equal to b. And then we're going to use the lasso method for this one. So we would say 10 to the 4th power equals c. Okay. And then let's see, how could we use this? So we could say we want a b cubed over here. So let's turn this into, let's cube each side. So if we cube each side, it would be 10 to the 15th is equal to b cubed. And then that would be, we're trying to find out what log b cubed c is. So then this would be log of b cubed, we know is 10 to the 15th power. Whoops, I didn't mean to put the parentheses there yet. 10 to the 15th power times what c is, which is 10 to the 4th power. So now let's use our product rule to say that this is going to be log of 10 to the 19th power. So then, let's see, these would just cancel out because whenever there's no number there, or they write a 10 there, which they wouldn't really do, they would just put the no number. These cancel out is one of our rules. And then we're just left with 19. So that would be C. So let's go to number 8. What is the value of the x-coordinate of the point of intersection where, oh, I forgot to do something, hold on. Okay, so let's go to the next one. What is the value of the x-coordinate of the point of intersection where this intersects with this? So remember, when stuff intersects, they're just equal to each other. These y's are the same if they're intersecting, so you can set these equations equal to each other. So we have ln of x plus 3 minus 1 is equal to 6. And also, if you're feeling discouraged by this, just know that there may be one question on the exam, if there is one, on logarithms. So I wouldn't get too hung up on it if you don't really understand. That's why this is at the end of the book, because I order it by priority, and other factors as well if stuff goes well together. But this is towards the end because it's a less common topic. So let's see. Let's add 1 to each side, so then we get ln of x plus 3 is equal to 7. And then, let me just think how I'm going to do this. Sorry, I got distracted. So then it would be, let's see, we're going to raise each of these, we're going to say e to each of these as a power. So you could say e and then make this into the power of that has to equal e to the 7th power, because think about it. Each of these, if you make e your base and you raise them each to the exponents would have to be equal for this equation to be equal. And the reason we do this is because there's a rule with logarithm stuff where if you have e to the ln power, these can cancel out. So then that helps you find what x is equal to. So then these would cancel out, and that would be x plus 3 is equal to e to the 7th. So then you're solving for x, so it would just be minus 3 on each side. So x is equal to e to the 7th minus 3. So that would be G. And remember, a lot of this is like, you could use your calculator for a lot of different stuff too. It's just going to take you longer. So which of the following is equivalent to this right here? X squared is equal to e to the 64th. And if you don't like the explanation, you can go somewhere else. That's fine. Sorry if you don't like the explanation for the person that said that in the comments. So then let's go to number 9. It says, which of the following is equivalent to this right here? Okay. So, what we would do this, I'm going to take the ln of each side, because remember, like, a lot of this ln stuff is, like, making you want to cancel out with an e, so you're going to think, how could I rewrite it so that ln can cancel out with e? Whenever I see e or ln, I'm kind of, like, thinking that. So I'm going to take the ln of each side, and I'm going to say ln of x squared is equal to ln of e to the 64th. And again, the reason I did that was because whenever ln and e are with each other, they can just cancel out like that. So then you have ln of x squared is equal to 64. And whenever you take the ln or the log of something, you can actually, there's a rule that says that the exponent can go out in front. So this is just 2 ln x is equal to 64. And then if you look in the answer choices, they're trying to get ln of x by itself. So we're going to get ln of x by itself by dividing by 2 on each side. So then that would be ln of x is equal to 32, so it would be A. So let's go to number 10. So for number 10, assume x is a positive prime number less than 10 and y is a positive integer. If log x 64 is equal to y, then what is the value of y? Okay, so let's see. I would just use the lasso method first. So x to the y power equals 64. So x to the y is equal to 64. And then I'm trying to find what is the value of y, and they said x is a positive prime number less than 10. So x is a positive prime number less than 10, so that means that x could be equal to, like, there's a bunch of possibilities. Well, not like a bunch, but a couple. A positive prime number less than 10 could be 2, 3, 5, 7. Any of those are positive prime numbers less than 10. So those are my options for x, basically. And then I'm trying to find out what y is. So if these are my options for x, I can just kind of like plug in and see like what the y should be for like which of these would work where I could get an integer value for y like they're saying. So let's see, we could say 2 to some power, that would work. 2 to some power is equal to 64 because that would be 2 to the, let me think, that's 2 to the 5th power is 32. So then times 2 would be 2 to the 6th power is 64. So 2 to the 6th power is equal to 64. So 2 to the y would be 6. So it would be h. So then let's go to the next one right over here. Why won't 1, 4, 8 work less than 10? Because it says positive prime number. So it has to be positive and prime. That's less than 10. So these are the only numbers that are positive and prime and less than 10. So then let's go to number 11. Suppose x is equal to all of this. Which of the following is equivalent to log of x? Okay, so how I like to remember a lot of these rules, because it looks like a lot more complicated than it is when you take the log of something, basically the exponent comes out in front of it. When you're dividing, that's when you can subtract the logs of each of them. And when you're multiplying, you can add the logs of each of them. So like I kind of remember that as like the rules instead of remembering all these different variables and stuff. And you're going to see what I mean in a second. So let's see. I actually don't have a lot of room on this paper, so I might do this on a separate sheet of paper. Let me get a separate sheet of paper really quick. Okay, so let's go and do this one. So you don't need logs for the SAT. This is for the ACT right now. So we're going to, if I look at the answer choices, they all say log of x. So I'm going to take the log of each side so that I get log of x is equal to something. So I'm going to say log of x is equal to, and then I'm going to take the log of this side. Remember, when you take the log of something, the little exponent, the 7, can come out in front. So this would be 7 times the log of all that stuff on the inside. So now what I'm going to do is I'm going to say, okay, there's division in between these two. So whenever there's division, it means that you can take the log of each thing and subtract it. So you can take log of the top and subtract it, and subtract the log of the bottom. So division means you can subtract between the logs. So then that would be log of x is equal to 7 times log of a to the 4th c cubed minus log of a plus b to the 6th power. And now, remember, when you are multiplying on the inside, that means that you can add the log of each. So we can say log of a to the 4th plus log of c to the 3rd is the same thing as this. So I'm going to rewrite it like that as well. So that's going to be equal to, and then log of a to the 4th, which I like to, some people will do like put the 4 out while they do this, but I like to write it in steps so that like students can see like the 4 being taken out in a different step. So that's what I'm going to do here. So I'm basically just saying, since there's multiplication in between, that means that I can add the logs of these. And then I'm going to subtract the log of a plus b to the 6th power. Now, remember, when you take the log of something, you can put the exponent out in front. So that's what I'm going to do. I'm going to copy down everything else, and then I'm going to say, okay, the 4 can come out in front, and the 3 can come out in front. And then I'm going to subtract log of a plus b to the 6th. So now, if you look at the answer choices, you're starting to get something that looks more along the lines of these answer choices. So now I'm going to distribute the 7 to each of the terms to find out what log of x is equal to. So 7 times 4 is going to be 28, so 28 log a, plus 7 times 3 is going to be 21, so 21 log c. Oh, this is bothering me, and this is bothering me. Okay, and then we're going to distribute the 7 to right here, the -1, that's right there. So this would be -7 log of a plus b to the 6th. So then, now let's see which of these is that exact equation that we have right here. I don't know why I wrote that little bracket. So we have 28 log a plus 21 log c. So it has to be either b or c. And then it's -7 log, so then it would be c. Okay, so now we're done with that one. Let's go to number 12. So number 12 says, given that log x plus, or log 4 plus log x is equal to 3, what is the value of x? Okay, so let's see. Remember, when you're adding in between, you could say that that's the same as just taking the log of those numbers multiplied, so log of 4x, if they have the same base, because like these have the same base of, there's basically no little number there, which means there's a 10 there. So we would say that this is log of 4x is equal to 3. So then now, let's see, we want to find out what x is. So then I can say, I'm going to use the lasso method to say 10, because if there's no number there, we assume it's a 10. So 10 to the 3rd power equals 4x. And then we can just solve for x. So you would just say 10 to the 3rd power divided by 4 in your calculator, and that would equal 250. So it would be h. So let's go to number 13. Suppose we have all of this. What is the value of x? Okay, so first I'm going to factor out the 12. So I'm going to say x is equal to 12 times log 12, 4 plus log 12, 3. Okay, and then let's see, I'm going to say that, hold on, did I do that right? Wait, log, yeah, I just factored it out. Okay, so I factored it out, and then I'm going to say, okay, if I'm adding, that means I can multiply. Sorry, I'm confusing myself, going back and forth between the rules. So if I'm adding in between logs with the same base, I can multiply these and just put it into one log. So it could be log of 12, and then 4 times 3 is 12, so log 12 of 12, basically, and then times 12, I'm going to copy over, and then x is equal to all of that. So remember, when we have like the same little number here as what's inside over here as like the big number or whatever's in parentheses, if they choose parentheses, those can just cancel out to 1. So then this becomes x is equal to 12 times 1, which is just 12. So it would be D. And let me just fix that. So that's number 13. Let's go to, I think there's 2 more. So then let's go to number 14. It says, suppose 3 to the x power is equal to, this is another one that's more common. Like if you're going to get log problems, it's probably going to be one of these, the lasso method problem or the lasso method problems on the exam. So suppose 3 to the x power is equal to 81, x plus 3. What is the value of x? So what we want to do with these types of problems is we want to rewrite it so that they have the same base, like the same big number is kind of like how you can think about it. So I want to turn these into like 3 to the something power. So this is already 3 to the x power. So I need to think, okay, how can I rewrite 81 as 3 to some power? Well, 81 is the same thing as saying 3 to the 4th power. So I could say I'm turning 81 into 3 to the 4th power, and that's all being raised to the x plus 3 power. So now I can just do power to a power rule here and multiply 4 times x plus 3. So then I get 3 to the x is equal to 3 times 3 to the power of 4 times x plus 3. So if they have the same base and they have to be equal, that means that their exponents have to be equal for this to work. So x has to equal 4 times x plus 3. So now I'm going to, what do you call it? Not multiply, distribute. Technically it's multiplying, but distribute the 4 to each of the terms inside the parentheses. So this would be x is equal to 4x plus 12. So then I'm going to subtract 4x on each side. It's going to cancel out on this side, and that's going to leave me with negative 3x over here is equal to 12. So then I'm trying to solve for x, so I'm going to get x by itself by dividing by negative 3 on each side, and that's going to give me that x is equal to negative 4. So the answer should be G for this one. So the 3's canceled. Technically, it's not necessarily that they're canceling. It's that, like, if I have, like, think about it with regular numbers. If I have 2 to the 2nd power, and I want to say, like, 2 to some power has to equal to the 2nd power, that means x has to be 2. Like, x can't be anything else for this to work. That's basically what I'm saying. That, like, this, if they're the same base and they're equal to each other, their exponents have to be equal to each other if the whole thing is equal. So then let's go to number 15. What is the value of this over this? And so this you could plug into your calculator. But if you, for some reason, your calculator like fails you on test day, what you could do instead is say, okay, this is log 327 is equal to x. And this is one of the formulas in chapter 4. So then we would say that this can then be used, you can then use lasso method to say 3 to the x is equal to 27. So then x is equal to 3. So it would be C.